with square? Okay, we'll just start. Sure, that's fine. That's fine. So on this one, first thing you should always do is, if you can, what should you do?
Make a graph.
Draw it. Yeah, exactly right. So where does cosine start? At 1. So cosine's going to go like this, right? And what's sine going to do? Like that, right? And you're going from, that's a little too high. I'll make it a little lower, sorry. About that, right? So you're going from 0 to pi over 2, which brings you to right about here, correct? So you have two ones. You have originally R1 and R2. Daniel noticed this too. What do you notice about R1? You're doing the area enclosed by these things, enclosed. So R1 and R2 are right there. So what do you notice about R1 and R2?
Are they equal?
They are identical. That is correct. R1 is equal to R2. So when you're doing this, you find that intersection. That intersection happens where? Where is sine equal to cosine? Pi over 4. So when you do each of these, you just have to do 2 times the integral from 0 to pi over 4. It's the same exact thing. It's fine. So for square, you're squaring it. So what's the upper function? The red one is cosine x, and then it's minus sine x dx, right? And it's squared. Can you do this one by hand? Yeah, you absolutely can. Let's do it by hand and then verify it with a calculator. At this point, you could just plug it into your calculator and be done. Honestly, the biggest thing I need you to take away from this is the setup. It's all about the setup on these. But this one in particular is something you need to remember how to do. So you have 2 times, what should you do at this point? You noticed this, Claire. What should you do to this one? Yeah, it's going to be cosine squared x minus 2 cosine x sine x plus sine squared, like this. Sine squared x, right? Dx. And what's really nice, what's one thing you can simplify really nicely in there? What's cosine x plus sine squared plus cosine squared? 1. So this is actually 2 integral from 0 to pi over 4 of 1 minus 2 cosine x sine x dx, right? Do you agree with that? How many integrals do I break that into? Well, that's 2 times the integral from 0 to pi over 4 of 1 dx minus 4 times the integral from 0 to pi over 4 of cosine x. Why is it 4 all of a sudden?
Because you pulled out that 2.
Exactly, I pulled out that 2. Can someone tell me what the answer is to this one? What is that? What is that one? What? Nope. 2 pi. So this one is 2 pi, and it's going to be because it's 0 to pi. What's the integral of 1? What's the integral of 1? No. X. So this is x from 0 to pi times 2, right?
Yeah, but I'm like trying to figure out why the integral is becoming pi.
Over 4. Thank you. That's just a mistake of mine. I'm sorry. So it's, excuse me, that was just a mistake in my writing. Good question. Thank you. That's what you're out, spot check me. That's good for you. Good for you. I've heard of some professors in colleges that build like one big factual error or lie into their lecture every day, and then they challenge the class to find out what it is. Like they do what, 1 per day. And I think that works really well in classes like economics or politics. In math, I think it would just kill you. So I don't, they're not on purpose, okay? They're really not on purpose. So this one's just going to be 2 times pi over 4. Agree with that? That makes more sense. So this one's going to be 4 times, and we have to integrate this one, right? How do you go about integrating this thing? What do you have to use? And I'll tell you, it's doable. What is it? It's actually quite easy. No, product is for differentiation. Yes? Yeah, you have very few tools. If I say it's doable, you look at it and go, can't simplify it. Let's try U sub. What's U going to be?
Either cosine or sine.
Yeah, which one would be slightly easier to use? Sine, because when you take the derivative of sine, it's positive. I mean, does it really matter? Not really. It doesn't matter at all. You get du over cosine x. So when you sub this in, what do you end up with? The integral from what to what? What's sine of 0? What? Is 0. What's sine of pi over 4?
Square root 2 over 2.
You have to change the limits of integration, right? You can't keep it as 0 to pi over 4. You cannot. So then it changes into cosine x times du over. And the magical thing that happens, this whole thing worth it. It cancels the cosine x, which is the entire reason for doing this. You now end up with pi over 2 minus 4 times the integral from 0 to root 2 over 2 of what? What is it? There's no cosine anymore. It's gone, right? Are we okay? Oh, there's a u in here too, right? Because we got It's the sine. Sorry, there's a u in there, right? I mean, can you put in 1? That's fine, right? So it's this. Is that a little bit easier to integrate?
Yes.
Yeah, absolutely. So what do you end up with? You end up with pi over 2 minus 4 times, what's the integral of u? 1/2 u squared from 0 to root 2 over 2. When you plug in 0, what do you get? 0. So you get pi over 2 minus 4 times 1/2 root 2 over 2 squared. What's root 2 over 2 squared?
It's
1/2 to 4.
Yeah, which comes 1/8.
No. This right there turns into 2 over 4, which is 1/2. 1/2 times 1/2 is 1/4. So pi over 2 minus 4 times 1/4. So that's going to be pi over 2 minus what? 1. Exactly. So let's just check something. So let's just recap this one more time. So you recognize first that they're equal. They're fine. You then do this out. And you have to use u sub. You have to use u sub right here. You cruise through this. What's the key? What's a really big pitfall? You have to change the limits of integration to be u values if you're substituting in u. That way you don't have to resubstitute at the end, and you end up with this answer right there. It's the same thing. You could write that on the AP test, and if you did write a decimal equivalent, like if you had a calculator to do this in, you'd have to go to 3 decimal places. On the AP exam, they would accept 2 different answers for the decimal equivalent. What would they accept? 50 or 571. Either one of them would be accepted. That will happen decently. That does happen every year or so. They'll have an answer with 2 of them. Yep. Correct? 0 to what? Pi over 4. It's the same thing, right? We're just doubling it. It's the same thing. And do you remember what the area of an equilateral triangle is in terms of its side? Side squared root 3 over 4 dx, right? So just simplify it a little bit first. So what do you end up with? Root 3 over 2 times the integral from 0 to pi over 4 of s squared dx. Is that correct?
Why is it 2?
Because 2 over 4 turns it into a 2, and I take the root 3 out.
Sorry.
Got that, right?
Yeah, I didn't see that.
Do we already know what the side squared is? That's exactly what we just did, isn't it? Isn't it exactly what we just did? So it's going to be root 3 over 2. Just remember, it's 0 to pi over 4 of cosine x minus sine x dx. Before we multiplied by 2, this time we're multiplying by root 3 over 2. That's it. It's the same exact thing. So have we already done the bulk of the work earlier? Yeah. Yes, absolutely. I'm not going to go any further. Now here's the thing. On the AP exam, on the free response, when they give you part A, B, C, D, and E, are they frequently interrelated? Absolutely. You take your results from B and put it into C, right? Or it helps you, like, will they scream it though? Will they say, like, use your results from A to do B? No. So if you ever get totally stuck on a free response question and you're on like part C, take a look at what you did in part A and B. It might give you a big hint onto what to do. They're not going to scream it to you. They expect you to see it. They also know that, let's say you made a small mistake. Let's say you need to take your result from B and put it into C. Let's say you got 17 instead of 15 on part B and you plugged in 17 instead of 15 into part C, but you did it right, but you plugged in the wrong number. Do you know how they grade that? They give you the full credit for that section. They will give you the full credit for that section because you got that section correct. If you do the right work with the wrong number, will you get the full credit on the one before that? No. But it's a fair grading system. We have a lot of smart people. Where did that come from right there?
The 8.
Yeah, when you square r squared, you end up with 1/4 times this thing squared. I'm just keeping it squared for now, and then I already had a 2 down there, so I made it 8. So you're evaluating pi over 8, the integral from 0 to 2 of x squared times x minus 2 squared dx. That's what you're integrating right there. Now, could you multiply that out? Sure. That's how you would do it by hand. Could you do this on your calculator? Sure. If you have a calculator, if this was a question on the calculator part of the exam, should you do this by hand? No. What is the most valuable thing on the AP exam? Time. Even if you cruise through this, money. What AP exam have I not been taking? Yes, you can do this by hand pretty easily, but it'll take you like a minute. That's a minute you should be spent on doing something else. You type that into your calculator, you get an answer, you're done. If they give a calculator, if it's a calculator, use your freaking calculator. And then make sure you multiply pi over 8. Exactly. I'm not going to do that up, but there it is right there. Be careful if you're... What?
Because 2 minus 2 is 0.
Yes, but 0 minus 2 is not.
Oh, that's where we went wrong.
So I'm going to draw a nice little picture here. What is this the equation for?
Circle.
Let's see. So that's circle with radius.
X.
Circle with radius.
1.
That's an L. That's a letter L. Circle with radius. L. Yes. Thank you. I did understand what you were saying. I was trying to see if anybody would verbalize it. So let's say L. What could L be? Any number you want. 2. I like that. Pony. No, not really. That's a very poor circle. It is very hard to draw circles. That's a poor one, but yeah, she's an animal with that. I totally get it. Yeah, she's about many more years of experience with it. It's very hard to do. You can judge a lot about someone by how they draw a circle. Mine, I'm working on it. So here we go. We're gonna make some cross sections. That's gonna be our footprint. That's gonna be our footprint. Our cross sections are gonna be a little different this time. Cross sections are going to be circles. So they're going to extend in front and behind. Is that okay? So what did I just create? This is a sphere of radius what? Of L. Sphere of radius L. Nice. Okay, great. So let's say we wanted to find the volume of this sphere. What's our leftmost limit of integration? Negative L. I don't know where 2 is coming from. There's no 2 in this. No, it could be 2. It could be anything. 2 is from any number set, okay? What's the biggest one? Thank you, right. Okay. What's the area of a circle? Pi times r squared. Now, when we look at one of these slices, Eli, if I look at one of these slices right here, let's say I look at this one right here, is that perpendicular to the x or the y axis? Is it perpendicular to the x or the y axis? It is perpendicular to the x axis. So we are integrating with respect to what? X. Write that in. I really say, please write out what you're integrating with respect to. That is helpful. So now if we're going to integrate this, we need to write the radius in terms of x. Does it matter if L is along for the ride? No, because it should be in terms of L. Do you agree that the volume of a circle is directly related to the radius? Yes. Does the volume of a circle of sphere change if L changes? Yes. So let's think about this. We need r in terms of x. Well, what do we have here? We know it's a sphere radius L. So what do we need to? So the radius here. Let's just draw that in. I'm sorry. The radius of each of these circles is right here. It's this distance right here. That's the height, correct? Also known as the y value. So we need to isolate y. Well, you've done that many times. What is y equal to? Plus or minus L squared minus x squared. Exactly. It's the square root of squared minus x squared. So that right there is our height. That is the radius of our circle. Do you agree with that? That's the radius of our circle. It's not the radius of our sphere. It's very different, right? So what is this going to be equal to? Pi, the integral from negative L to L of, what was it?
Plus.
Yeah, which one do we take? Why is it plus or minus? Is this a function? No, we had to break it up into 2, correct? So the upper part, and that's the big question here, the upper part of this is 1/2. Here's the upper one. Which one is that? Is that the positive or the negative? It's going to be the positive because it's above the x-axis. It's the square root of L squared minus x squared on. So that right there is our radius of the circle. The square root of what? L squared minus x squared dx. Can we integrate that? Absolutely. Mainly because you see this little square right there? Is that our saving grace? Yeah. If that square wasn't there, are we kind of totally stuck? Yeah, we can't use substitution on that. There's nothing on the outside of the radical to cancel with a substitution. So you square it and you end up with pi negative L to L of what? L squared minus dx. Do you agree with that? Is that good? How many integrals do we break this into? Yeah, it's going to be integral of L squared dx minus pi times the integral from negative L to L of... Do you agree with that? Is that correct?
Yes.
Oh, it seems right. Okay, what's the integral of L squared? L squared x. From what to what? Negative L to L. Hold on, I got to pause for 1 sec. Don't worry, it's something small. I just can't figure it out. Let's just finish this one for a sec. What's the problem here? Yeah, you end up with pi times L cubed minus, oh no, we don't. So it's minus negative, that's what it was, L cubed. Because you're plugging in L for x,
Oh,
right? So there we go. So what does this turn into? What's it turn into? 2 pi L cubed. Do you agree with that?
Why didn't you do 1/3?
Oh, that's what we didn't do.
Integrate.
Yay! This is the missing thing. Why are you guys doing this to me? I've never done this before. Just like totally forget to integrate. Why? You hate me? You hate me or something? This is on the record. They hate me. Okay? That's what was getting me like this is not right. There should be a 3 floating around in here. Okay. So, was that on the record? Let's just check that. It sure was. Okay. So we end up with pi times what? Oh, no, it's correct. It's multiplied by x. Why? You're not supposed to do this. Oh, man, it was right.
No, it's minus pi times
You're forgetting the
1/3 x to the third.
What?
No, 'cause it's not
We haven't done the integral yet. The other one is going to be pi times, so we were correct. This is 1/3 pi x cubed from negative L to positive L. So we were right. I'm sorry. So you guys weren't lying to me. It was totally fine. I'm just going crazy. It's totally fine. You guys aren't bothered by that. So it is 2 pi L cubed. Are we really okay with that now? Yes, we're really okay with that. So now we just have to make sure we don't mess up the algebra on the second one. We definitely messed it up yesterday when we did it. So it's pi over 3 times what? L cubed minus what? Minus negative L cubed. Is that correct? So you end up with what? 2 pi over 3 L cubed, correct? So you have 2 of something and you subtract 2/3 of something, so what are you left with? 6/3 minus 2/3. 4/3 pi L cubed. We just found the volume of a sphere with radius L. What is it? Look familiar? Yeah, that's the volume of a sphere. This is yes. Of radius. When I did this question yesterday, I used the radius as r as well of the sphere and the circle. Don't do that. One thing that's really hard to do, because it's like 2 radiuses, be really careful. So that's why I used L. So what was this entirely reliant on, though? We used a formula right at the beginning of this that if we didn't have, we couldn't finish this. We used it right here. Area of a circle. Have you ever proved that before? The area of a circle is pi r squared. It's an entirely different proof and is much harder. This right here is essentially just a result of the area of a circle being pi r squared. We haven't proved that. We can later, but we haven't proved that yet. I mean, think about it. Have you ever proved that the area of a circle is pi r squared? No, you haven't. This is a cool result of pi r squared. So we have been generating volumes so far by making slices, correct? There are other ways to do that, and they're really cool. I totally missed that one. I'm sorry, I missed that recording. So let's just recap that one time. What are the 2 most important things to do? Where the squares are.
And
What you're integrating with respect to. Washers. And in AB calculus, we don't even need to cover cylinders, which is one more method. But when you rotate things, you get a lot of circles. Can you add up circles to your heart's content? Yes. By far, the hardest thing about these questions is the setup.